Hello everyone, I'm Professor Pekka Abrahamsson, the head of the GPT-Lab at Tampere University in Finland. At our lab, we are exploring how to utilize AI agents to automate various tasks in software engineering. Today, I'm excited to discuss our most recently developed project, CodePori. The main objective of CodePori is to autonomously generate code based on high-level specifications or descriptions. There are several tools and models such as ChatGPT, Google Bar, Bing Chat Enterprise Llama, MetaGPT, and Palm Code that facilitate code generation from high-level descriptions. However, these models are limited to generating tiny systems with a maximum of 150 lines of code due to their line limitations. To address these limitations, we developed the CodePori model for large-scale code generation. Our model is capable of generating thousands of lines of code within less than half an hour and at a cost of few dollars. Currently, we have not published our project on GitHub, as we have submitted a paper for publication. Once the paper is accepted, the code and model will be publicly available. In this video, I will demonstrate running our project using high-level specifications. We will use face recognition, face registration, and face mask detection as examples for this demo. Now let's move forward and start running the code to demonstrate some of the capabilities of CodePori. Before we run the code, let me first explain how AI agents collaborate with each other to generate code. First, the manager bot, which is Agent 01, takes the description and breaks down the project into multiple modules. It then sends these modules to the next agent, DevBot1. This agent is a senior Python developer who builds the initial code. The code is then sent to DevBot2, which ensures that the code is built efficiently. Following this, Finalize Bot1 reviews and updates the code accordingly. In parallel, Finalize Bot2 works with Bot1 to review the code for each module. Finally, the verification bot analyzes the code to ensure its high quality. Now let me first show you the input description for the project. The description is Python-based facial recognition system for automated attendance tracking. As you can see on screen, we also provide more detail about libraries, which libraries must use and how the buttons should work. But if you don't want to put much detail, then it's also fine. You can just write two-line description or specification for generating the code. Now let's run the project. First, it displays the number of modules that will be used and provides a detailed description for each one. This includes information such as the name of each module and how it should function. Now it starts generating code for the given description. Each module will be saved to a file automatically. It will take around 20 minutes to generate code from the given high-level description. After that, we will open the folder in VS Code to run the code. As we observed earlier, this project comprises 5 distinct modules. Each of these modules is designed to be saved within the same directory where you execute the code. It's important to patiently await the completion of the code generation process. Please bear in mind that the code for each module will be stored in this same directory, making it easy for you to access, copy, and save each module to your preferred location. It's also worth noting that the process of generating the entire code can take approximately 20 minutes. This duration is necessary to ensure that all components of the code are accurately and thoroughly produced by CodePori. Once the code generation is complete, you will have the opportunity to individually copy each module and save them into a separate file for easier management and reference. We recommend waiting until the final code is generated before proceeding with copying and saving the modules. This approach ensures that you have the complete and final version of each module, facilitating a more streamlined and efficient process in integrating the modules into your broader project workflow. We have to make sure that all the libraries used in this code are installed. Also ensure that all CSV files are in the same directory where all the data will be stored. As seen in the code, a har cascade file is required for image recognition. Therefore, this file also needs to be downloaded and placed in the same directory where the project is saved. This may sound complicated, but it is not. Now we can copy the module and save it into a new folder. And then the next step is to open the specific project in VS Code to run and test the code. Now let me open the file and show you that we already create new CSV file, which is attendance CSV and registered users.csv. We also downloaded the HARSCADA file, as you can see on the screen. Now let's back to the code and let's see how the generated code work and how is that. Now let's run the file one by one. As we can see, here is the output of first file where we register our ID and face. Here we write the new ID and name for each candidate and then click on Start Face Registration button. Then the camera will turn on and register our face. This data will be stored into registered.user.csv file. Once we registered our data and face picture, then we start running the next module. It is important to note that the data stored in same directory, because the next module... Now let's run the next file. In this file, our faces will be recognized, as you can see on the screen. After that, we run the last file, which is used to manually record the data. As you can see on the screen, when we execute the file, it presents us with a specific user interface. This interface is designed for user-friendly interaction, facilitating easy data entry. Once we input the data, the system is programmed to store this information in the attendance.csvi file. This process is a crucial aspect of data management within the application, ensuring that all entered data is systematically recorded and retrievable